All right, we're back on camera. We're going to go into example number 2 now. Is that too boring? Do you want to make it more interesting? Make it harder? All right. There we go. That looks more interesting, no? You do realize that it's this.
Yes, now I do.
Okay. So I would take the ln of both sides, personally. I would bring the g of x down. Notice I haven't taken a derivative yet. And then that's what I would take the derivative of both sides. Something that should be very straightforward. Now do calculus. There's no calculus up until there. So, ln y. Why do I choose ln? Because I know the derivative of ln. It's 1 over y times dy by dx. Could I have used log base 10? Sure. It would be 1 over y times dy by dx times 1 over ln 10. You see why I'm choosing to use ln? Because, yeah, any logarithm work. I could use log base 3. There are times when log base 3 might be a better idea because it simplifies something out. But if I was to do log base 3 here, the derivative would be 1 over y times 1 over ln 3 times dy by dx. And I'd have that ln 3 sitting there. Now, the answer is that it would reduce out with stuff over here. But this is easier, I think. You're going to stop writing this line probably. And you're probably going to go straight to this line. Ooh. Could you see yourselves doing that? So what I did was I took this part and we brought it down in front. So now we want to take the derivative of both sides. And to be honest with you, I'm kind of lazy. And I'd like to teach you to be a little bit lazy. Does that convey what I want it to convey? So it's going to be 1 over y times dy by dx equals the derivative of the first times the second plus the derivative of the second times the first. And again, if you wanted to put in other steps in there, I'm really good with that. This remember, is a product. And the final answer is going to look something like dy by dx equals y times 6x ln x plus 3x squared plus 5 over x. Now, that's ugly. It's right, but it's a little bit ugly. There are a couple of things here that I would do. First of all, I'd change y to x to the 3x squared plus 5. Secondly, this 6x ln x, I don't know. I'm okay with that. This is over top of x. I would like the whole thing to have one denominator. So I'm going to get a common denominator of x. So this is going to give me 6x squared ln x plus 3x squared plus 5. And this is where the back of the book will give you a different answer, and you're going to think you're wrong, and you're not. Do you see how this is x to the 3x squared plus 5, and this is x to the 1 on the bottom? I'll rewrite it one more time before I do the final simplification. And the final simplification would simply be this. come the 4? How'd I get rid of that 5? That's right. Because it was 3x squared plus 5, subtract 1. The bases are the same, right? So you subtract exponents. Neat question. We okay? Any questions on that?
So you know the step where you got the same denominator? Like
Yeah.
If we left it right there.
If you left it here,
Yeah.
it's not fully simplified. Now, it's not wrong. You've done the derivative. Now, fully simplified, I'd be looking for this. Right? And fully simplified, I'd be looking for this. If you didn't do this, and if the question said fully simplify, you're setting yourself up to lose some marks. If it's a textbook, the back of the book might go this far. It might stop there. If it's a multiple choice question at university next year, they might stop here and you've stopped there. I want you to be able to do the simplification. Isn't it a necessity? Being able to do it is, but is there a difference between this answer and this answer? No. If I was subbing in a value, x equals 0, x equals 1, no way would I be doing that. Okay?